Hello and welcome to using MySQL to build data applications. This is going to be a tutorial about obviously using MySQL uh, to build big data applications, but when I mean big data, it could be two things. It could be uh, there could be two problems that you're addressing. Either it's a problem of scaling, as in my system already has a lot of data and I would like to be able to make the existing features more performant or be allowed to to get more volume. And the other problem is reporting, in the sense that you already have big data and you are asked to make use of that in some way, um, to either give more insight to the business users in your organization, or give aggregated reports to your customers about how they are performing. And I'm going to focus today on this side of the big data problem. So what is the problem with big data? Basically, it's as if you have a very large table with millions or billions of rows, and in order to do the reporting that you need to do, you need to gather all this information from this table, process it in some way. However, what does that mean, like in terms of the underlying hardware, of the physics of it? You have a hard disk. Let's pretend it's a hard disk, and in order to get the certain rows from the rows in the table from the hard disk, you have to go over many different places of the hard disk. So if it's a large amount of data, obviously that's more time consuming. If the data is fragmented across different places in the hard disk, that means you have to spin more. And once you have that, you need to get that data into the CPU, roughly, to aggregate that, to process that, manipulate it into whatever way you need it to, and then you produce a report which you later provide to your users, and they're happy about it. Not sure if you can see that. Okay. So this problem actually has been going on for a very long time. How are we able to, with existing hardware, existing technologies, get more data faster to be able to process it and turn it into reports? So many years ago, a person called Ralph Kimball, who is the main, or one of the two main contributors to the data warehousing came up with data warehousing, wouldn't say really movement, but technology, came up with an idea in 1995 or 6, where he said basically no matter what the technology is, it will always have to go through a large number of rows. So how can we design our database that we are able to produce reports without asking the database to make these very resource intensive operations? And what he thought was, what his solution to this problem was basically to create something called a summary table. And a summary table is an aggregated version of this table, and obviously smaller and less rows. The data has already been taken from here and summarized here. So when you access this summary table, it's obviously much easier to get the rows and much easier to give back the result. So let me give some examples about what that would look like. So let's say you have a table and it has orders. It's like a basic e-commerce site, and you have usually 100,000 rows per day. So that's not really an issue for usually any relational database. You store those rows with the database. That's fine. But over a period of time, let's say a year, you have quite a large number of rows. So you start to have 36 million and a half rows, and that could get cumbersome. And in some cases, it could be much more than 100,000 rows days. But let's stick to this example. So you want to create a report from the orders table, and you want to know, the business users in your organization want to know how certain products are doing across particular dates. So what you could do, you could create a summary table like this, and for the sake of clarity, I'll write a select statement here that will explain the contents of the summary table. So you'll have select. So let's say we need date, because that's what was requested, and we need product ID. And we want to get the aggregated details of revenue. And that's it. And then we group by it. Date, the two keys, date, and product ID. And this is now the new summary table, so we can call it product revenue summary. And this has, let's say we have 100 products, so this will have 100 rows a day. So obviously you could, after generating this table, you could provide this table to your business users and say, do whatever you need, find out whatever information you want to gather. So let's say, for example, if someone were to query for product 13A and how it did on weekends. So perhaps you would find a table for weekends, for dates, and get only weekends, and may perhaps interjoin with that table, and you'll get the answer very quickly, and your users will be happy because of it. A different example, or a different summary table could be, for example, we're interested to know how the products are selling across a particular geography, and in this case, let's say city. So what we would need to do for that, let's say city ID isn't recorded in the orders table, so we would need to enrich the table a little bit, and the way we do that is we interjoin it with the addresses table. And what we would do is we would basically, I'll just write it here, we would do select, let's do O for order, so select date and city, and we do sum from, conditional join addresses A on maybe using address ID. Did I spell address correctly? Okay, address ID. Group by date and city. And we would fill up a new table called city revenue. So here we have two summary tables, two different ways of slicing the data. Now, you aren't exactly limited by the number of summary tables you can have. Obviously, they take a certain amount of space, and they also take some effort into creating. We'll get into that soon. What you could have done, for example, here is you could have added city to product. So you have product, you have here date, product ID, and city ID. Make it a larger summary table, but you can get at the data in two different ways. Or perhaps you could then have a more extensive summary table with higher granularity that you could search for product and city and date. That could be a user comment. It depends, but if you're only interested in getting to the data you're only interested in this slicing the data in this way or slicing the data in this way, you have currently two summary tables, and this particular summary table has saved you an inner join, so that could be quite valuable in terms of performance, saving you an inner join. So those are the two examples. I'd just like to quickly give another example of what happens nowadays in some other companies. So some, let's say, social networks already kind of use the idea of summary tables in their systems. Let's say they have lots of servers spread geographically, and this is EU, this is Europe, sorry, this is North America, this is South America, and this is Asia. And in order for them to get reports that they're interested in, what they would do is they would get data from all these servers into, let's say, a MapReduce system. So in this case, let's say Hadoop, for example. And remember, this is we don't need the exact once it arrives here, we don't need the exact data from them. We need the aggregated data to go to another database or another summary table. And once the data from here is aggregated, it goes into a reporting database. Now, depending on their needs, this can be a MySQL database. If their needs are greater, it could be any number of commercial or open source solutions which can handle larger amounts of data. But the theory is very similar to the example of summary tables. You get data from someplace, you aggregate it, and you put it in a reporting database, and then your users access this database and query it according however as they see fit. You can directly from Hadoop also create reports on your own, but these are static reports. You can't change your query. The report is as is. Whereas here, if they want to change the query or get different information once they discover there's something wrong with the data, they want to get slightly more information according to what they found, then they can query this database, whereas here it's static. So as with a lot of things, you're adding basically another layer to your database system, a subsystem of summary tables, and you need to now basically create that. You need to make sure that data constantly arrives into those summary tables, and you need to monitor that everything goes accordingly as well. So there are two ways basically of doing this, or maybe more than two ways, but two paths that you can do this. So these are the summary tables here. One is real time, and one is batch. Batch can be basically either on interval, so for example once an hour, or it can be at a set time, 2 a.m. for example, when no one's using the server and it's very easy to do these heavy processes. The idea is, for example, let's say interval of once an hour, so you're getting all the orders that happened over the last hour, aggregating it, and then putting it into the summary tables. In set time, same principle, but for a whole day's worth of data, so it's becoming a bit large amount. But in these cases, it's important to note that the summary tables are only refreshed, once an hour or once a day. So if that's a business decision, that's okay. Then you can go ahead and do that. What else? No, I'll come back to it. And obviously with not so obvious, with these kinds of system, you need to set up monitoring, because you can't just take for granted that the data has arrived. You can't just create something like the select statement that I created, put it in a cron job, and hope that nothing goes wrong. You have to make sure that everything there's no warning messages, no error messages, that the data arrived as it should have. Regarding MySQL, to set something like this up, you can basically use the select statement that I gave, with a certain where clause depending on your interval, and insert into, sorry, if it's on the same server. So for example, you have one server or a reporting server, and you have the data coming in through application. This is the regular orders table. So you can set up, let me just write it down here. So for example, this is your database, and here is your main schema, and this is your reporting schema, and your orders table is here. And here, for example, you would have the two summary tables, and you would use the insert statement here, insert to, take it from here and insert it into these two, per table, so insert it into that table. Right. The other way of doing this is perhaps a bit more slightly more confusing, but sometimes it's a requirement by certain databases that you do select into out file, some kind of file, and then some kind of file into on the hard disk, and you load data in file command in MySQL. And this is sometimes it just helps with replication or helps with certain requirements of database vendors, but please do whatever is more convenient for you. I would add a tip here. For example, it's where, and then there's a group by. I would also recommend adding order by null, because MySQL by default would have the group by. Also, there'll be like an invisible order by the columns that you chose, and that means you have to do an additional file sorting. And if you don't need that or you don't require it, you can do that auto. You can add auto by now, and that will remove it. You can, let's see, you can put primary keys or unique keys on these, and you can replace into if that's more convenient, or insert ignore into. You can, oh, this is what I want to say. So if for example, the data between the intervals, the data, it's only new data arrives, then that's fine. But if, for example, there's a chance of older data being updated, then you have to perhaps include more than 1 hour worth of data into your interval. You have to maybe delete older data, or, as I said, replace into or insert ignore into. Older data that may be updated, you have to either record which data was updated, or you can just bulk say, the last 3, 6, 7 days. If any data was updated in that period of time, then please update the summary tables with that data. That's something you need to look out for. With Hadoop, you can do this batch thing with Hadoop. So Hadoop Hive or Hadoop Impala, that I've heard Impala is quite good recently, and this is still batch. Still batch. I would say though that relational database regarding the group bys, these kinds of aggregation relation databases are still very, very strong. You would want to look at Hadoop if, even though it's quite strong, it's still just one database and it's not parallelized very well. If it takes a very long time, you may want to include Hadoop in some way, but just the difference is here that this is one server and Hadoop can be 5, 6, 7, 8 servers to aggregate your data. So you would get it. You can get your MySQL database into the Hadoop cluster and either back into it, or you can have a specific reporting database. Up to you. Regarding real time, in terms of MySQL, this basically means triggers. Or your application can understand to do it itself. So the idea is, once you update the regular database on your install statement, once you update the regular database, you have to update the summary tables as well in the same instance. So obviously this is a bit of an overhead. If you have high load on your databases in general, and you can't take this additional write overhead, then you may want to consider batch, or you may want to consider other alternatives if the requirement has to be real time. And I think even for social networks, this is starting to be like a real requirement. So you would have, basically, when you have insert statement here, you would, if it's for example, you have a sum aggregation, then you would say, for this particular line, add the amount that came into this one row into this table, and then add it here. If it's been updated, change it. If it's deleted, remove it. There is also a lot of other functions, average, min, max, and that can be more complicated. There is a link that I'll provide from another website that speaks about it, that gives details about how to write triggers for that. If it's not an issue to add these triggers, the overhead isn't an issue to add these triggers, then it's a bit more convenient, because you don't need to monitor it so much, in that if you insert it and something goes wrong in either one of the database, the insert itself will fail, so you will fix it then and there. If you're using a trigger to log something and then do it later, then asynchronous, then it's not exactly real time, then you may need to still monitor it. But trying not to confuse you, real time basically triggers, and you can find here how to set that up. I think I'm almost at the end. So just to summarize, even as technologies progress, if you want to speed up your reports, it is a good idea to have summary tables. And you can use the reports of those. It's very common in places that have a lot of data, and I'm sure that it can help you. It does take a bit of additional design, and I haven't spoken about it here, except that I've given an example where we've removed an inner join with the city aggregation table. Something you'll have to look at a bit more, and as you've noticed, I haven't given too much code examples, so this is really just an overview so you understand what summary tables are. So that's it. Thank you for watching my tutorial. If you want to contact me, this will be my email address, and this will be my website/blog, where you can find out more information that I've written in the past. Thank you very much.